G'day guys. I don't think people still get the gist of what's going on. Okay, this time I've got a mono coil on, right? This is a mono coil. It's an old Nugget Finder Advantage, which had the middle of it cut out. I think this one actually failed and I got it going again or something. But anyway, it's pretty old. Been kicking around for a while. Okay, I've got this connected up to a GPX 4500 and I've got it on a gain of 1. It's in mono mode. It's going to make noise. There's nothing I can do about that. It's going to scream and carry on a bit. But what I'll do, I'm going to turn off all the switches. Oops, we're in darkness. Hang on, I've got to put on the main top light. We need some light. There we go. So we've got some light now. I'll show you something. I'm going to show you this with hot rocks, shielding and unshielded. So those wires there, they're basically unshielded going in. Not that the Faraday shield has any effect on this whatsoever, because I did do masking tape on it, went around it, did the same thing at the hot rock, still made the same noise. So anyway, that's what it is. Turn this on. You should be able to hear it because it's going to be quite loud anyway, I'd say. I don't need 2 mics. So take it you can hear that. I've got this handheld, so hopefully I don't put my fingers over the lens or whatever. Okay. I'll give this hot rock on the coil windings. Nothing. Hot rock near those unshielded but basically solder blobbed wires. Oh, that's the phone. Damn it. The phone's going to set off. Anyway, I'll try and do this. I really need 2 people because I can't get my arm will have to go out a bit. There we go. Get the phone back and the arm out. Okay. Now this is ground balanced, right? So those windings in the coil, even on this, it's not a GPZ, it's a GPX. Still, hot rock is interacting. Anywhere near those wires. I'll even go into the coil a bit, near those wires, over the Faraday shielding. Still ground balanced. So you can see, oops, I'm too close. Hang on a sec. I'll turn that noise off so I can talk. So what you're seeing there is a hot rock. Even in here where it is actually grounded and covered, it still goes off anywhere near those solder blobs, which could be in any coil. Okay, I could wrap them up in Faraday shield and still going to go off. So this proves a point that there is a reason to put some sort of ferromagnetic shielding on those solder joints. Now what I'll do, I've got these little ones here. These aren't doing anything so far up the cable and don't have enough inductance anyway. But what I'll do, I'll just get this one big one here. We'll put it over the connections like so. It's not perfect. It's still sticking out, of course. But what I'll do, I'll try and, you can see it's still sticking out everywhere. It's leaking. Those solder joints are leaking, but we'll try it like this. Okay, I'll show you something. So this could be why a lot of the coils, previous ones, are all reactive to hot ground. I don't know, maybe this is the biggest overlooked thing since sliced bread. Hot rock, relatively ground balanced. Oh, what? No signal? Only when I move that core, of course. Get back there. Okay. If I bang the core, it's going to go everywhere, but... Oh, look. No signal. Oh, no signal. What's this telling you? This is telling you unshielded connections in all our old coils. are interacting with the hot ground and hot rocks. Anything with a whole heap of magnetite, maghemite, iron, whatever, it's going to react. I'll just turn the noise off again. And that was just the most simple shielding that I could do. Now, you could do it with this. You could stick that over it. But my tests show these are causing a reaction with the ground balance on the coil, and thus you'll have some mixture of two separate ground balance points trying to be nulled out at once. You're trying to null this out and you're trying to null out the ground, where these are not reactive. So my opinion is don't use that. Use that or similar. It knocks off the proximity. When you swing your coil, you're swinging your coil over the ground. That's not ferromagnetically shielded or anything you want to call ferrimagnetically, or it's actually ferromagnetically. Depends on the structure of the core, by the way, if it's ferrimagnetic or ferromagnetic. But anyway, because I'm using a mix of cores, I'm probably interchanging between the two terminologies. So basically can spin two domains at once in the ferrimagnetic mode. But anyway, won't go in there. It gets too complicated. Sorry about that. Anyway, it just look at it. It works. It works. Okay. Hot rock. Bang, bang, bang. With that sitting there, no reaction. Take it away. Whoop, 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 whoop everywhere. Okay. So, like I say, I have actually put a bit of tape over it, painted it, stuck it on, and tried that. But I needed that like that to show you. It doesn't make any difference with the tape on or off. It made no difference. And that's the shielding tape. Like I could put anything on it to shield it, Faraday shield it. It just it's not reactive enough. There's enough Faraday shielding around here for what I'm doing. I'm just holding it away from it even. I'm not really coming into contact. Even up here, it's not going to affect there. And still goes off like a Bondi tram. It's an Australian saying, by the way. I don't know what it actually means. Yeah, I think a Bondi tram is a tram, like a little train thing that goes through the middle of the streets, and it goes off. I think what the Bondi trams did is probably jumped off the tracks, off like a Bondi tram. I don't know. Someone can probably say that in the comments. You've got to come from Sydney to know that. I'm in Melbourne. Not Melbourne, Ballarat, but closer to Melbourne than Sydney, so you can inform. But seeing's believing. How about I'll just do? Oh damn it! I need two hands to do this. I can do it. Hang on. I'll get this. Whoops. Get back here. I'm going to put the small ones over it. I'm going to move that one into the middle of the cable. This cable, I've had it clamped at one stage. It's got a bump in it, so it's really hard. I might actually end up. It's sort of stuck. I can't push it. I mean, it's got a big bumpy lump in the cable. Damn it! And if I push them all the way over, it's probably going to crush the wires together. They're probably a little bit close, obviously. And if it squashes them together, well, the detector's not going to work. But same damn effect anyway, same core material. Yeah, do that. And just doing that, it works. So if you actually had a longer, even like this, but a cylinder, had that wrapped in there so they can't touch together, put a sleeve on it or something, like a piece of tubular, I'll think of maybe tubular nylon or polyethylene or something like that, or something that's not going to squash together and short out. You can probably use something very small sleeve of this, stick it on there, and you got rid of all that reactants to hot rocks. That's quite substantial, guys. If you don't realise what that actually means, you could be going hot ground, and these uncovered soldered connections can be having a signal die back from the ground really quickly, but couple in with this and go back and forth or whatever it does, I know there's a reactive interaction there. So, like I said, go on to geotech1.com and see if you can get Carl to give a really detailed explanation on it, because he probably will. He probably watches my videos. So, Carl, if you feel inclined and you've got enough time, you can probably do a write-up on something like that in a very, very clear, not so technical way of doing it, because no one will understand it. Well, the guys on the site will probably understand, but people coming in on the site won't. So, it's hard to keep all camps happy with this sort of stuff. But there you go, guys. That proves it on a mono for you anyway. Like I was saying, I was trying to prove it on this in relation to the GPX, but I didn't think I'd be able to do this because of the amount of electrical noise. But I've got this detector dumbed down a bit, so it's usable on a mono in here, which is really amazing, by the way. And that's that. That proves a point. Okay, so seeing's believing, hearing's believing. That is the issue with all our old coils. And guys, you've all probably been out there running over the ground with non properly. Well, it's not shielding. Well, it sort of is in the way it works. It actually diverts the magnetic field. Shielding doesn't. It just acts as a Faraday. This is nothing like a Faraday shield at all. It actually diverts the magnetic fields and stops the interaction with the outside environment and keeps it all enclosed. So, in that regard, this should be, in my opinion, a major, major improvement for any mono, double D, triple D, double D mono, triple wind coils, anything. It should be some massive improvement overall. And it doesn't skew the ground balance as a ferrite core does. So these carbonyl reduced iron type cores, which is the mix 26, initial permeability of 75. That's just the specifications of the core, the way it behaves. They're fairly temperature stable too, this mix. And yeah, anyway, guys, go do experiments. Do experiments on your own course. Like I say, you get these little ones off eBay. I'd use these. If you can get all this neat here and just push them over on the joint, and put some masking tape around it, paint it with some black tape if you want a Faraday shield. That, not that you need to, but you could. It's not going to hurt. It's probably going to make it work better if anything, or have no effect. Painting it with carbon paint. But look, guys, that is how it works. The hot rock reacts with that. So hot ground, close to that, with a big massive hot ground, where you've got it's hot particles and it's not homogeneous. It's patchy. It's going to go woo woo woo, make your coil sound off, and chuck your detector out of ground balance. In my humble opinion, anyway. I hope that explains it a bit better than what I was doing before on top of the coil. This is in the core, in the coil. It's with the windings, and it's over the solder joint. The other thing you could do, if you really wanted to stop the solder joints interacting with your coil, right, with the ground and the coil and everything else, you could actually get this and make your join up here somewhere. Step it out a bit, and keep it away from the ground. If you keep the joins away from the ground, you're going to have less interaction. But that's just the way these are made, and it is what it is. Like I say, this is just an old coil that did fail, and it's been resurrected. As you can see, I think it had some of the paint come off around the outside, and I redid it. I think it. No, hang on. There you go. Had a crack in it. There you go. Had a crack in it. But yeah, I think I just rejoined it here. I painted it there, which joins that with that. Doesn't make any difference. Works perfect. But beforehand, it was cracked or something. But I think someone ran over it. I think that was the story. Ran over it or something. and that stuffed up the coil. But it's working fine now. You can actually go and you can hook that up and use it as an actual stick in a skid plate and use it as a mono. Just put a mount in the middle, 2 bits of plastic, drill a hole between them, bit of I don't know, what would you use? Liquid nails? I don't know. ABS glue, melt it, whatever. Use acetone, melt it on, stick it together, and away you go. So don't use it in the wet though, because it'll stuff up. But like I say, you can do this. Try it on your own coils. Tell me how you go. I am very interested. I'm going to do it on my own coils, by the way. Some of them anyway. Maybe that the big one around there. Down there it is. There it is. That's one I made ages ago, and that has got no ferrites in it. But ferrites is its own thing. Powdered iron type cores are their own thing. There's nothing similar about them. They're similar, but they're miles apart. Put it that way. It's like a golf ball and a tennis ball. They're both round. Okay, I think I've got that explained. But don't play tennis with a golf ball, and the other way around, of course. But yeah, so that does prove a point. You can experiment with that. You could Faraday shield it. You could do whatever you want. But we are looking at removing that interaction with the ground. So obviously, it does it on those detectors too. Those things. Well, those things. It does it on those. So be wary, and see if we can improve the game, improve the the nugget count. That's what it's all about, isn't it? No one goes and does this for pure exercise, do they? You want to make money out of it. Gold now, Australian dollars, $100 a gram or so, $100 a gram, and that's just scrappy gold. And you find nice nuggets, then you got improved nugget value. I'll tell you what, I see so many people just go, stuff it, and, melt down their nuggets. I'm going, you could have probably got an extra 50% for that, but I see it all the time. Don't melt your nuggets down. Anyway, my opinion. So yeah, this will be video 3 in the series of playing around with solder joints in coils. So it starts off with the GPZ X coil, and then it moves into this sort of stuff. But anyway, it's just a muck around, prove a point, rough as guts. That's rough as guts. It's not a finished commercial product, is it? But you could, make really good coils. I don't know. Could you have patented that? Could you have? No one I know of was ever using powdered iron except for me. But I've been using it for over 15 years. So, and I've already published it 15 years ago. It's all out there. So, and it's written up on websites and everything about doing this. But no one ever picked it up and did it. No one. They all went ferrite. I went, okay, whatever. Anyway, it's probably been the public domain now too long anyway. So, be something you probably can't do. I don't even know if you can get. Oh, you can probably. I don't know. I wonder if you can get carbonyl powder, mix it with a binder, and paint your area there with it, like paint it on, like mold it on or something. I don't think it would work. I don't think you can do that. I think it loses its permeability. It needs to be crushed up and sintered and formed, in a hard lump. I don't think you can just, use it like silly putty or something and stick it on there. Don't think it'll work. Anyway, I'm excited. That's freaking, I feel like, a 5-year-old discovered a hammer and nail and some wooden blocks. It's exciting. This is exciting stuff. Most of the stuff I do is just mundane and boring all the time, really. And you do something like this, and you actually go, hang on, this actually is got merit. Let's prove it out. And yes, you prove it out, and it does work. So that's that. Like everything, it's good. It's good. Like even with modifications, and then on the detectors, you build something up, you test it, and you go, oh wow, that's really good. That works fine. But after the 500th board you've built up, you're sort of a bit, yeah, same again. It sort of loses its sparkle a little bit, if you're just doing the same thing all the time. That's why I like jumping around, trying this, trying that, experimenting. I've got a lot more stuff than this. My God, I'm overflowing with stuff with detectors, and like, this is pretty well. Some people look at that and say it's mundane, isn't it? But look at the effect you get from it. Look what it does. Maybe now you don't dig up hot rocks. I don't know. Is that possible? Less response to hot rocks, less interaction with parts of the coil. I don't know. And you find out. I'd say it would definitely give less interaction with hot rocks, because whereabouts in your coil are you picking up the hot rocks? On the windings, or you get them where the coil joins? Some of these things too join very close to the middle. I think a lot of coils, they're joined out about here somewhere. That's very much a very reactive spot, because it's equal distance around the whole coil wind. So maybe that's something worth looking at as well. But yeah, just put those things on your joins. Put them on your joins, or like the little ones, just put them on the joins. Whatever. Or see if you can get or get onto micrometals and see if you can get. They got solid pieces, and they're probably about that long. They're probably that as a solid piece, I think. I've got to go back and have a look at the dimensions, but something like that anyway. And they got them ex stock. Be really, really good. Anyway, that's that. Catch us later.